everyone, welcome to New Breakpoint, Microsoft's digital event series designed for developers by developers. I'm your host, Michelle Sanford, the Developer Engagement Lead for Australia, New Zealand and Asia. We broadcast on the second Thursday of every month, and if you join us on the day, my guests and I will answer your questions live in chat. As you might know, New Breakpoint has expanded to encompass Asia Pacific, meaning we now bring interviews with developer experts from all over Asia. Today, we are welcoming back Rakesh from Agile Insights. Now, I don't usually welcome people back for a second episode in the same series, but Rakesh holds the record for the highest number of views for a New Breakpoint episode, outperforming Scott Hanselman and Scott Hunter, and local favourite Damien Brady, and in fact, even his former colleague Daniel Fang. So I thought I would get him back to take his demo to the next level.
Yeah, thanks for the warm welcome, Michelle. And it's actually my privilege to be a part of your channel again. Thank you for inviting me the second time. So, hey everyone, I'm Rakesh and I'm actually a principal consultant working at Agile Insights. So, at Agile Insights is actually one of the leading Microsoft partners in Australia. And we are a team of data and AI experts who help customers in building AI solutions on Azure. And a little bit more about myself. I've been working on Microsoft technologies for over 15 years now. I've been working on a wide range of projects that involves large language models and all the recent innovations and the cool features from Microsoft. I'm really excited to be part of this session today, and I will be talking about Microsoft agent frameworks and other cool things.
That's perfect. So last time you were here, we talked about AI agents, and our last episode was built using Azure AI Foundry and Semantic Kernel. So what has changed since then? And tell us all about Microsoft Agent Framework. What gaps does it fill?
In the demo that we did last time, we built a single AI agent and that had access to an MCP server. The MCP server exposed our product inventory and also gave the agent action tools to manage the orders. And we relied on Azure AI Foundry service to handle some of the heavy lifting and things such as maintaining the conversation state, calling the tools, and managing the responses back to the LLM model was with the help of Azure AI Foundry agent service. And we also used Semantic Kernel to structure our prompts and orchestration logic.
Mhm.
And at the front end, we built a small React application to talk to our backend, which was actually built using a .NET chat orchestration API, which orchestrates the calls to the AI agent hosted on the Azure. And the scenario that we talked about is a contour bike store, so where the assistant can help you answer questions around products or the bikes, and make some recommendations and also help with some of the order and billing aspects of the purchase. Right. Overall, it was a solid example of building a customer support assistant using AI Foundry agent with tools. But as with most of the real world demos, there were some gaps. The first gap was the scale and the complexity. A single agent works fine at start, but in more scenarios, more complex scenarios, it quickly becomes a bottleneck. And you will end up with one agent trying to know and do everything. So let's say you want to scale this assistant by adding more capabilities such as managing your refunds and talking about policies. And that's going to be hard to scale and even hard for the LLM model to reason about. So more instructions, it might actually get lost. So this is where we split your solution into multi-agents. And what we really need is multiple agents specialized in their own domains, each focused on a particular problem area, and some kind of orchestration layer that decides which agent should handle what, right? So that it delegates that to the specialized agent based on the intent and the context. So we'll talk about those orchestration patterns a bit later in the demo. The second gap that I wanted to highlight in the previous solution is tight coupling. So we built this custom orchestration API for the client to talk to the agent. So that meant the client was tightly coupled to the endpoints or the API that the orchestration layer would provide. And the big question here is, can we expose agents that we build in a more standard way so any client can discover and interact with it, right? So that's one of the other gaps. And
Mhm.
the third was visibility. So when you are building an agentic solution, obviously there is a lot of exchanges in terms of the messages that goes to the OpenAI across agents, shared context. So it's hard to actually troubleshoot and keep track of what exactly is going on, what data is being exchanged. So you need really a good logging or observability as a requirement. And without that, it's going to be hard to debug or even improve your agents. So that's an important feedback for you to start working on your prompts and like debug these issues. And finally, the vendor lock-in. So we don't want our solution to be tied to a single provider. So we want the flexibility to swap agents, maybe try different models or like mix providers without rewriting the whole solution. And this is where Microsoft Agent Framework comes in. It's an open source framework for building AI agents and multi-agent workflows. And it comes and it actually combines the strength of both Semantic Kernel and Autogen frameworks. So I've used Semantic Kernel in some of my previous projects, which is a framework that's enterprise ready and it can actually help you build AI and scale AI solutions. And Autogen is more focused on multi-agent collaboration. So that's another framework. And yeah, Microsoft Agent Framework is actually a combination of these two. So it's built by the same team. It supports both SDKs, .NET and Python again. And the key features that I would like to highlight in this demo today is using workflows to orchestrate the multiple agents and exposing the agents through OpenAI compatible HTTP endpoints. We spoke about like the tight coupling. So the way we solve it is to expose our agents as OpenAI compatible HTTP endpoints, same interface definition, so that any client can actually interact with your agent. And Microsoft Agent Framework also provides a tool. This is mostly for the development phase. It's called Dev UI, and it's a lightweight standalone application for running agents and workflows in Microsoft Agent Framework from a playground. So you can actually select a player agent. You can actually visually debug and test your agents and also workflows before integrating them into your applications. So that's another thing. And tool invocations. We have seen that agents can also call external tools, but in some cases, it might actually require approval from the user. Like it's called a human in the loop pattern. So where the human is actually going to approve the tool invocation before you can actually go and execute the tool. So we're going to see an example of that as well in the demo. Again, this is one of the features from the Microsoft Agent Framework.
Rakesh, so you mentioned about building workflows using the framework, but why do we need the workflows when the agents can decide on their own what to do?
Yeah, that's actually a great question, Michelle. And yeah, so when I started with building AI agents, I mean, I like to actually talk about AI agents before we answer or talk about workflows. You need AI agents for applications that require conversation-based interactions or ad hoc planning and maybe some degree of autonomous decision making. And we don't need AI agents for tasks that are well defined and deterministic. We don't want to actually introduce AI agents if it's actually a strict set of activities that you want to perform. So there is no agentic use in there. And this is sometimes like where we go wrong. We want to actually build everything as AI agents. And as you can see in the diagram, so this is what normally an AI agent does. The steps that AI agent takes are dynamic, right? And it's determined by the LLM response. So you actually input your query or your scenario to an LLM and let the LLM decide on the next steps. And it decides that based on the context of the conversation and the tools that's available. And as the conversation would progress, the agent may need to call different tools based on the user's intent again. And this continues in the loop until the agent finally reaches a response. And for our solution to be scalable, you need to break down the complex tasks into smaller subtasks and have specialized agents to handle those subtasks. And you can test these agents individually and reuse them in different scenarios. And this will give us like many advantages. I mean, some of them are mentioned on the slide here. So you would see improved reliability because you would have tested that in isolation, and easier maintenance, of course, because it's more modular. You can actually plug new agents into your solution after testing them in isolation, and also other benefits like better performance and like flexibility to swap a newer agent as needed. And of course, like when you have multiple agents that are working together, you would still need control on the overall flow of the conversation. And this is where a workflow comes into picture. And it depends on the use case or your business scenario. Again, some processes will need sequential execution of agents, while some can be executed in parallel. And you can actually build workflows using Microsoft Agent Framework to do the overall orchestration logic. You can actually build a workflow using imperative code, or you can actually have a more declarative approach. You can visualize the workflow. So Microsoft Agent Framework supports that. It also allows you to share context between the agents and maintain the state across the workflow. So this is actually one of the critical self features. So where you wouldn't have to worry about like, how do I share the context or how do I pass the context across the agents? So you can actually make use of some of the out of the box features to orchestrate or like to solve some of these problems.
Can you use Microsoft Foundry agents with Microsoft Agent Framework? I mean, how do they work together?
Yes, absolutely. Actually, in my previous demo, it was using AI Foundry agents, but in the demo that we'll be doing today, I'm still using Azure services, Azure OpenAI service, but I'm actually spinning up a known agent. I'm not actually using AI Foundry agent. But having said that, Microsoft Agent Framework is designed to be a unified framework to build AI agents and also multi-agent workflows. So what this means is you can create agents that can talk to AI Foundry agents or custom agents that talk to OpenAI chat completion or any other LLM providers. So all the agents they implement the same AI agent interface. We'll be looking into the code shortly, but it's called I agent interface where all these agents provide an implementation for, and so they can be used interchangeably to your solution. And when you're building a workflow, you can maybe use an AI Foundry agent for to solve a certain thing, and you can actually mix that with your other custom agents as well. However, the framework actually is still in a preview, and you might actually encounter some rough edges, but the goal is clear. It would actually support different types of agents.
When stuff is in preview, people, it's a good time for people to start trying it, learning how it works, figuring out what's going on, reading the docs, but not building stuff for production because you don't really know whether it's going to, when it hits GA, it will be the same as when it was in preview.
Yes, yes, yeah, that's right, Michelle. It's good to be involved in the early phase, and the repo you can find heaps of examples which talks about which many different areas and also uses different providers. So that's definitely a good source of information.
It really is like a workplace because you have the agents from all sorts of providers. Just like in your workplace, you might have people from different outsourcing firms or different
Correct.
contractors or consultants and all of that. So yeah.
Yeah, that's right. Like, I mean, agents are aimed to actually mimic humans. So I guess, like, I mean, that actually answers it. So you will have different attributes, different personas.
Let's talk about hosting now. How can you start interacting with the agents that you build using the framework?
Yeah, so in the previous case, we had this custom orchestration layer. So let me just go back to that slide. Yeah, so this is actually the chat orchestration API. It was an ASP.NET Core application, which was hosting some endpoints like the chat endpoint, or maybe getting the list of all the agents in your solution. So this was a custom implementation. But with Microsoft Agent Framework, you can actually choose to host your agent using OpenAI compatible HTTP endpoints, again on an ASP.NET Core application with just a few lines of code. And this allows you to integrate your agents with any OpenAI compatible clients or tools. And if you're using agents, maybe to run some of the background processing, which means it should be running for a long time, you can also host your agents on Azure functions, or maybe even durable functions, which have more timeout values. So let me just quickly take you through a quick demo of how you can host an agent on an ASP.NET Core application. And I'm using Visual Studio 2026 here, just recently updated, going through the new features. And let me go to the program.cs file. And this is where you will see some of the configuration where I'm using Azure OpenAI endpoint. And the model that's being used is GPT-4. So you can actually add them into your app settings. And I'm also adding some logging here. And this is where we create the chat client, the OpenAI chat client, which uses Azure OpenAI endpoint. And I'm also adding some tools to this agent. And this is where we create an agent. And it takes the name, the instructions, and tools. And I'm using the chat client, which is actually linked to your model. So that is how your agent is talking to the model. And this is actually the most important step where once the agent is created, I'm actually publishing that as an OpenAI chat completion endpoint. And this does all the heavy lifting. And here we are saying we want to expose this agent that we created, so Bikes agent, as an OpenAI chat completions endpoint, or even using the responses endpoint. And I also added some sample requests just to show you how we call this agent using the same OpenAI chat completion interface, and what the responses looks like. So let me just quickly start the server. So it's using .NET 10. Right, so the server is up. And now from Visual Studio, I can browse to this file and click on this button that says send request. So the name of the agent is within your path, the request path. And you can see that it says V1 chat completions. Okay, let's try that again. So the question that I had asked was, what bikes do you have available? So it goes and calls your agent, gets a response, and even the format that you see is the same OpenAI chat completions format.
Mm.
And this is where you see the answer. Here are the bikes that we have currently. Right. So that's actually the hosting part. And again, as I mentioned, you can also host your agents on Azure Functions as well, in case you want to run your agents as in your background processing jobs.
You said you have upgraded the demo that you showed us last episode using Microsoft Agent Framework. Can you show us what has changed in particular?
Yes, sure. Let me bring up the slides again quickly. All right. Right. So it's similar to the previous scenario where we have a customer support assistant that can help users with the product information. And I have upgraded the solution to .NET and also migrated the agent implementation to use Microsoft Agent Framework. And we also use workflows to orchestrate the multiple agents.
Mm.
So in this demo, we have two agents. The first one is the product inventory agent. Its responsibility is exactly what the name suggests, handling product related queries. It uses the same MCP tool that we built in the previous demo to fetch the product information from the inventory system. And the second agent is the billing agent. This agent is responsible for pricing and payment logic. For the purpose of this demo, it uses a mock function to calculate the pricing. But yeah, you can actually also connect this to a real system, and this could be an actual backend. So just to keep it simple for the demo, I'm using a mock function. And the key point here is that each agent is focused and easy to reason about, and the workflow decides when to call which agent. The other major upgrade that in this demo is the client application. So in the earlier version, we built a custom React application. And in this version, I am using something called Copilot Kit for the chat interface. So Copilot Kit supports agentic UI, agentic user interaction protocol. And we'll be talking more about this protocol later. So we know that MCP protocol, the model context protocol, is for the tool invocation, and A2A or the agent to agent communication is actually a protocol for how you can interact with other agents, remote agents. And this protocol, which is agentic user interaction protocol, completes the picture by standardizing how clients can discover agents, send messages to agents, and receive the responses. So it's a standard around the interaction between your agents and your client applications. So which also removes the tight coupling and makes the client far more flexible so that they can talk to any agents. All right. Let me just quickly bring up the demo. Yeah, so this is actually the application that I built. It's hosted on Azure on an app service. It's an ASP.NET project, and it has a simple interface. I'm using Copilot Kit for the chat interface. And yeah, so when we log in to this app, it shows me this greeting message, and we can actually choose any of the prompt templates that's here. So we'll start with browsing the bikes in the store. So if I click this button, it will send a question as show me all the bikes. And this is where the agent or the workflow gets triggered and starts pulling the data from the product inventory. So these are some of the bikes that's available in the store. And now maybe I can actually pick any of these bikes and ask more questions. Can you provide more details about the bike? So yeah, so it actually has some details about the pricing, the location, and whether the bike is actually in stock or not. And so maybe let's actually go and order this bike. Okay, so I would like to buy this one. All right. So, I mean, actually, in a real scenario, it would not be this quick, right? So you would actually have to browse more details, go through the shipping, and just for this demo, I'm trying to keep things simple. So as soon as you say I want to buy it, like there is a trigger to your billing agent, and the billing agent, let's say it has access to a function which would process your payment. Like it has all the payment details, but obviously it needs your approval to go and submit the request to process your payment. So this is actually the pop-up that comes up, and this is dynamic. This is not like your UI driving the logic, but this is actually on the agent, the server trying to execute a function, and it sees that it needs an approval from the user and sends an event back to your client, and the client responds to that event by showing this pop-up. The client actually, the agent passes all these details. So we'll see how this is actually built and managed in the code. And now, when I say approve payment, the client again sends a message back to the server with approval notification. And the server goes and executes the function now because the approval is done. And you can see the pay message that says payment is approved and your order for the bike has been submitted and thanks for the purchase. So this is actually a simple workflow, but it touches on some of the foundation elements of the workflow. So where you're orchestrating multiple agents and you're actually using tools, and some of the tools also require human intervention. Like you expect the approval from a human to go and execute the uh, tool or the function. All right, so let me just go back to the slide and talk a little bit more about the workflow.
Mhm.
Yeah, so this is actually what we saw. When a user sends a message, it includes, I mean, the user prompt and also the conversation context. So I'm using AGUI protocol. So the Copilot Kit is actually supporting the AGUI protocol. And the control that we are using from the Copilot Kit, it actually grabs the user prompt along with the conversation context. So it's maintaining the conversation context at the client side, and it's sending that to the agent, which is the workflow endpoint that we built. And the first agent that receives this message is the triage agent. And its job is to analyze the user's intent and decide which agent should handle the request next. So it has access to the product inventory agent and the billing agent. And the selected agent, based on which agent the triage agent decides to hand off, would receive the user prompt and the full context. And it provides or performs its task and generates a response. And once that's done, the control returns back to the triage agent. And at this point, the triage agent has two options. So it may decide to call another agent, or it may decide to return the response back to your client. So this is actually the manager or the agent, the main agent, which is making all the decisions. And this pattern also makes your workflow dynamic and flexible rather than fixed. You can probably think of adding more agents in the future and have the triage agent aware of it so that your solution can be extended. So in future, you may probably think about a shipping agent or a policy agent added to the workflow, and without any change to your client call, your solution will still work because it's actually talking to your workflow, not to individual agents. So which is all abstracted under the hood. All right. So I use this pattern just to demonstrate how to build workflows and how to host them in Microsoft Agent Framework. But obviously, you can use other patterns to build more complex workflows based on your business scenario. And I would like to also talk about the approval workflow. I mean, this is actually the favorite part. And when we saw that, like in the demo, when we placed an order, you noticed a pop-up asking for the approval.
Mhm.
And this UI interaction is not handled or not hard coded, I should say, in the client. And this is what was happening behind the scenes. The billing agent, like which is here, sitting behind the AGUI server in the workflow, has access to a process payment tool. And that tool is configured to require human approval before it can run it. And when the client attempts to call this tool, and again, it based on the prompt that we said that I want to go ahead and buy this bike, and that's when the triage agent decided to hand over to billing agent, and the billing agent then decided to call the payment tool. So when the agent attempts to call this tool, the framework detects that the approval is required and will see in the code like how this is done, and then returns a response indicating back to the client application that an approval is required. So the client receives this request. So you can see that actually the client also makes the server aware that it has a tool and the client side where it can support approving a request.
Mhm.
So the server is aware of it. And because the server knows that client can actually handle the scenario, it would go and return a response or raise an event asking for an approval. So uh, once the user approves, this is actually dynamic. So when an event is received, it actually shows this UI. And once the user approves, the client sends another approval response back to the agent. And this would let the billing agent continue to execute the tool and process the payment. So this is actually the end-to-end logic, and it's dynamic, right? Like I mean, it's so simple. Just by having that specification on your tool, you can like protect your function from executing without a human approval, right? So this is actually handled, all the heavy lifting is handled with from your framework itself. And I would also like to show the code quickly. Yeah, so this is actually the code that's being used in this solution. And we have a host. It's again an ASP.NET Core application. And just going through the individual steps here. So we are using OpenAI telemetry. We'll be looking at some logs later. And we are reading the config for details about your Azure resources. And we are creating a chat client using the Azure OpenAI endpoint, and then exposing these agents over OpenAI chat completion endpoints or response API endpoints. And we are using in-memory conversation. We are storing the conversations in memory so that we can actually use this in a dev UI. I'll bring up dev UI shortly. And this is where we are creating agents with their own personas and tools. So for example, the product inventory agent, you define the instructions, and you also assign tools. And in this case, the product inventory agent has access to the MCP server that we built last time, and you actually assign that as a tool to this agent. Similarly, we also have the billing agent with
Mhm.
its own instructions and tools, and the triage agent. So let's actually have a quick look at the triage agent. And so this is mainly talking about the routing logic, where it says you have access to the product inventory agent and also the billing agent, and based on the prompt that you receive from the user, you have to route that to the correct agent. So that's the triage agent. And then this is where we create a workflow. We actually make use of all the agents that we created here. And we're trying to build something called a handoff pattern. So where an agent decides who to hand off the execution after it finishes its processing. So it starts with the triage agent, and the triage agent can hand off based on the system instructions and based on the context to either a product inventory agent or a billing agent. And similarly, a product inventory agent, after it finishes, it would hand off to a triage agent, and a billing agent would hand off to a triage agent as well. So once this is all added, you create a workflow agent. So workflow can also be exposed as an agent. So this is where we are saying this is the workflow which we built, and I'm actually exposing that as an agent again, and I'm registering that as a singleton. So it can be used by the dev UI. And this is where we are exposing the workflow or the agent that we built over the AGUI as a AGUI server. And also we are exposing this on dev UI. All right, so let me just bring up dev UI quickly. And this is again like used during the development phase. It's not for production. And this is going to help you trigger your AI agents on the playground and yeah, so do most of the testing. So let me just bring that up. Yeah, so let me call this agent from the dev UI. Yeah, by the way, like as we saw last time, we can also consume the agents as OpenAI chat completion endpoints. I've just added that here as well. And yeah, so dev UI is registered. So let me just go start the server and bring up the browser. So it's actually running on localhost 5001 port, and the path to dev UI is you just actually add dev UI at the end. And once you're on this page, you can see all the agents that are registered in your host. And we have three agents, for example, product inventory, triage, and the billing agent. I can also see the workflow. So if I select the workflow, you can see what we built in our code. This is more visual. Obviously, it helps in making sure that we have the right handoff. So it starts with the triage agent having access to product inventory, billing agent, and the control going back to the triage agent. So you can actually use the tool to maybe test some of your scenarios. For example, if I say, can I want to all the available bikes, the response that we should be expecting from a triage is the handoff. So it says like handoff to product inventory agent, right? So then
Mhm.
actually your workflow will hand off to product inventory agent and start continuing the process. So you can actually use dev UI to test your agents individually, and you can also have access to the tool calls if there is any tool calls that are made, and also the logs that comes out of this agent execution. And yeah, so this is actually one great tool when building your AI agents.
I love when it shows you like the little diagrams and all of that. It looks like such a great tool and it helps during the build phase. But how does it help during production? And are there any other tools that can help with observability and monitoring?
Yeah, that's right, Michelle. So this is mainly for development phase, but you can also push all your logs into Open Telemetry. And I have also registered some logging here. So where we are saying use OpenAI telemetry for the chat client. So any messages that actually goes to your model will be a part of your logs. And also with your agents, like if I'm actually talking to my agent, it uses tool invocations, it uses the models. So all those details will be logged as well. So when I say enable sensitive data, this would actually log even the request or the messages that's exchanged between your agents. So you still have control on it. If you want to disable that for production, we can actually do that. using this option. And I have started my Aspire dashboard to capture these logs. So when I interacted with the dev UI, with the agents from the dev UI, it was producing the logs and it was actually pushing that to the endpoint that have registered, which is in my app settings. Oh, sorry. Yeah, so you can actually pass an endpoint for your logging, but from your app settings. But by default, it's actually using this endpoint. So where I have my Aspire listening and waiting for the logs. So if I go back to the browser, I can actually see the dashboard. So this dashboard is running from Docker. So I have the instructions on the repo where I'll be sharing the details about the code and how to set up the dashboards and run from your Docker. So that's going to be in the link. So what happens here is when I'm actually interacting with my agents, it pushes the logs, which I can then see on the Aspire dashboard. So for example, when the product inventory agent was invoked, I can see that there was a call that was made to the model, which is ChatGPT 4, and I can see the request. Here, if I want to know what was the message, I can actually select this and see that the message from the user was, can you list all the bikes? And this is the response that we got back. And we can also see that there was a call made to the tool. So it's pretty comprehensive. And this is actually the level of information that we would need because we have a lot of actors in the solution, many agents, models. So you need visibility to all this information to fine tune or maybe troubleshoot some of the errors.
You mentioned AGUI before we went into this tool. What's that one for? What's that all about? What are we trying to solve with that one?
In agentic application, the traditional request response model between your front end and the back end no longer works effectively. And this is where, like when I say traditional model, this is where a client makes a request and the server returns the data, the client renders it, and the interaction would end. You would have worked with some of the applications like even GitHub Copilot. And if you have observed that a little closely, the interaction with the model is quite different from the traditional applications, right? So the first, the agent don't just return the final answer. So they often stream some intermediate work back to the client, and it could be partial responses, or it could be some reasoning steps, or it could be some progress updates. And so the user can see what's happening on the server or on the agent real time. And second, agent may need more input mid conversation. So after firing the user prompt, the agent may come back and ask you for more information, and it could be follow-up questions or clarifications, and it would pause the execution until the user provides additional information. There is actually you can see a sense of bidirectional method message exchange, and this isn't a single request anymore. It's actually a back and forth interaction. And third, agents can influence the UI itself, right? So based on the context and the user input, an agent might decide to open a panel. Like if you look at GitHub Copilot again, like the agent may decide to say, okay, I have to run the script. Can you run the script? Because it knows that maybe the client or the Visual Studio Code knows how to run a script. So that's the response that you get back from the server. And based on the context and the user input, an agent might actually decide to trigger maybe a confirmation dialog or maybe a show form or highlight certain options on the UI. So the behavior is always non-deterministic, and you can't actually fully predict it ahead of the time. So the responses will vary, and that's where the interaction is more dynamic. And fourth, but not the least, agents need to share context with the client. So this is actually the shared state between the agent and the client. The agent and the UI need to stay in sync so that across multiple terms, remembering what's already happened and what's actually in progress. So this is exactly the problem which AGUI or agent user interaction is designed to solve. So let me just actually show you or go back to the slide quickly. So what is AGUI? To summarize, it bridges the gap between your autonomous agents and a human-friendly user interface. So this is what allows agentic applications to feel natural and responsive, and especially when humans are a part of the loop. And agent applications break the simple request response model that dominated the front end applications in the pre-agent era, where a client makes a request, the server returns the data, and the client renders it, and the interaction ends. So this is no longer the case.
I love that.
Yeah, so this slide summarizes what we spoke about AGUI protocol. We said like it's going to be bidirectional, which means like you'll get stream response from the server, and the client also can go back to the server with more information as necessary. And thinking steps. This is where actually the server keeps the UI updated in terms of what's being done on the server, so there is good feedback for the user. And shared state. So the state is shared between your client and your server. And front-end tool calls. So the server is also aware of the tools that are available on your front end, and it can decide when to call some of these tools. And we did actually see this in our demo as well, where the front end made the agent aware of a client tool that was required for the approval. And when we wanted to do the payment processing, the agent decided to call the tool, which was to get the request approved. And that's one of the examples. And obviously, apart from your approval, you may also require human in the loop interrupts for other scenarios, such as editing your user prompt, which we have seen like in GitHub Copilot, where you can actually go and edit your prompts and maybe a retry or maybe cancel the user prompt itself without losing the context or the state of your conversation.
I feel like there's so much more stuff than there was even last time that we talked. And like maybe, maybe the best way for people to learn like how this all fits together and how it works is to try and build something themselves. So if what would you say are the next steps for someone that wants to get started with Microsoft Agent Framework?
Yeah, sure, Michelle. So I was actually going through the GitHub project for Microsoft Agent Framework, and there is lots of examples here on Microsoft Agent Framework. So this is actually the uh, project. I'll share this link on the chat. And you can actually see examples for both .NET and Python. If I maybe go into this folder, there is samples. That's actually for different scenarios. I start maybe with the getting started section. You can start with the basics of interacting with an agents, like how to run them, how to actually manage the conversation, how to talk to different providers. So this is one good source to get started. And obviously, there is a lot of information on the Microsoft documentation, and there are some Learn modules as well, which I'll be sharing that on the chat. But yeah, so I would say like get your hands dirty, download the repo. All you need is an OpenAI endpoint, or you can also use GitHub models because that's free, and you can actually get that OpenAI model access and start running your examples and learning more about Microsoft Agent Framework.
I've definitely been doing most of my building in GitHub using those free models is yeah, a really fun way and a really easy way to get started. But now I see this agent framework stuff, I do definitely want to build something a little bit more ambitious than what I have been doing so far. How long did it take you to upgrade that demo to become what it is now?
Yeah, to be honest, it was straightforward, Michelle, for me, because there is also documentation on Azure about how you migrate your earlier AI applications that was using semantic kernel to the new Microsoft Agent framework. So that helps. And also to build solutions using Microsoft Agent framework, we saw that it's very few lines of code. So it's easy, and you can actually get started with something very quickly. So to migrate the existing solution, there were two things. One is upgrade to .NET 10, which was again like using Visual Studio. It was very straightforward. And also with the help of Copilot, of course, where you can always have your pair programmer sitting next to you and like answering your questions. And yeah, so Microsoft also has documentation for upgrading from semantic kernel to the Microsoft Agent framework.
I think that like people might be a bit overwhelmed because these things seem to be coming out all the time. First, everyone was talking about MCP, then A to A. Now you've mentioned like a bunch of things in collaboration with Agent Framework. Should they be worried, or do you think it's that the things are coming out faster and they are trying to simplify them and make it so that people do less work compared to how much they had to do when it first came out?
Yeah, that's a good question, Michelle. So I think there is focus on two aspects in my view. So abstraction, so where you don't need to get into the details of everything like under the hood, and which is good. So you can probably focus more on building a business applications rather than figuring out like how to actually make a tool call work or how to maybe like talk to a model. So abstraction is a key to move faster.
Mhm.
And apart from that, interoperability, like working in a common ecosystem. And that's also a focus for us today. So we talked about MCP, so where it's all about like how LLM can talk to a model in a standard way, or how you can actually consume a remote agent in a standard way using A2A. And now we also talked about AGUI, which is your client application talking to your agents in a standard way. And this is actually good so that you stop writing custom code for some of these common scenarios and you can actually leverage something which is already out there. And yeah, so I feel like, I mean, obviously there is things are moving fast and there is more things to learn and adapt. But I think like we are getting closer to the ideal scenario, I guess.
Mm. I think like during a few times during the session you talked about, open source, you talked about connecting to multiple models through different ecosystems and opening everything up. Um, I think one of the things I would stress is that the reason I build in Azure is because what is important to Microsoft is that governance, privacy, security, and compliance aspect. So even if I want to have the flexibility of accessing different clouds and going to different models and reaching different ecosystems, I can still be confident that the home that I am building in is providing that level of governance and security overall. Would you agree with that?
Yes, 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 totally, Michelle, because actually this is a framework which can work with any providers. I mean, like we talked about like using AI Foundry agents also, which comes with a lot of governance out of the box. I mean, in terms of making sure that it's provided the right access to your backend tools and right access to your data. So you can actually use Microsoft Agent, which is in your AI Foundry, take care of all your governance and security requirements, and think of Microsoft Agent Framework as framework, which is an abstraction on any of the AI, like to build your solution. But your underlying components like are managed in the platform, which is Microsoft platform, and that ticks most of the boxes for you for governance and security compliance requirements.
Perfect. Well, as usual, we we have been talking away, but I had better finish now. So I do want to thank you for showing us your next level demos. They have provided amazing insights as usual, and I know that everyone will be coming back to these again and again as they learn to build with Agent Framework. As we've mentioned, we're going to link all of the resources from the episode to our GitHub log, and we will continue to answer questions online for another 10 minutes or so. So thank you, Rakesh, and thanks everyone for tuning in, and look forward to seeing you all next time. Thanks, Rakesh.
Thank you, Michelle. Thanks, everyone.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can. If you're not staying for the Q&A, thank you for attending and we hope to see you again soon.